Okay, guys. First example here. I don't know why. Oh, I don't know why that's there. This last. Okay. This part right here. So I'm scratching that out. So you guys can scratch that out as well. But first, I want to go over these terms. First thing, an open sentence, guys. An open sentence is just a mathematical sentence like this equation that has a variable in it, and it can take different values of the variable. It's open. Okay. If we had a statement like this, 3 plus 5 equals 8, this is a closed sentence, okay? But when a variable is there, it's open for values of the variable to be plugged in and evaluated. All right, so that's what we're talking about with an open sentence. Guys, this word right here, get it now. You're going to use it forever throughout calculus, okay? The domain. The domain stands for x values. It's another word for x values when we use a t-chart. Okay, and another word for x values is input. Okay, input and then output. The range, we've talked about domain and range, it's not in here, but the range stands for the y values. No, that's not right. Range stands for y values. Okay, and if I'm writing, you should be. And another word is output. Okay, so we need to be aware of these two similar terms. These two sets of vocabulary here: domain and the range. Today we're just dealing with the domain. All right, values for x. Also, today we're dealing with solution. A solution to an equation is a value that makes a true statement when I plug it in. Okay? When I plug it in, it's true. If it's false, then it's not a solution. Root, the word root, is another word or a synonym for a solution. Okay? If I plug in a variable and it works, we can call it a solution, or we can call it a root to the equation. Okay? This is generally for equations higher than the power of 1 or degree 1, like quadratics and cubics. Satisfy. This means the value of the variable makes a true statement. It satisfies it. Okay? And then the solution set. Solution set is the set of all numbers that make an equation true. For instance, the other day, when we were doing that quadratic, there were two answers that made it true. Two values of the variable that made it true, correct? So the solution set was 1 and 3. Both of those numbers were a part of the solution set. Sometimes it's just one. Sometimes there are no solutions. It's an empty set. Okay? Sometimes it's more than two. All right? So now at least we know what those words are. Now, guys, you're going to kill me for this. You're not going to kill me, but you're going to hate me. But what's new? So I'm not worried about that. But tonight, you're going to have problems, and they're going to say, plug in all of these. I want you to do all of them, even after you find one, because another one may work as well. So you have to do it for every value that they give you. Don't be lazy. All right, here we go. It says the domain of x is 1, 2, and 3. So those are the three numbers that I need to plug in. 5 times, and I'm going to leave my spot, equals 9. I'll do this one in green. 5 times minus 1 equals 9. And I'll do the last one in red. 5 times the blank minus 1 equals 9. Let's start off with 3 since I have the red pen in my hand. Plug in 3. I'm going to get 15 minus 1 equals 9. 14 equals 9. That's not true. I know that. My mom taught me that. All right. Let's do the x equals 2. All right, so 10 minus 1 equals 9. Look at that. 9 equals 9. Okay, that's good. So if I were writing this, whoa, that's bad. If I were writing this with braces, now that was going to be good braces, and then Mr. Smartboard messed up. Okay, I could put 2 in there because it does work. Now let's go ahead and try the blue number, which is going to be 1, the first one. So 5 minus 1 equals 9, or 4 equals 9. That's not true. So this solution set only has one value in it, 2. You could also write it, guys, as x equals 2. That's the solution to the equation. Good job, guys.